So 3.3 is up next for us. We'll be needing to draw some straight lines. So if you're in the classroom, there's some bookmarks up front or anything that'll help just act as a straight edge to make a straight line with. And again, the 3.3 notes are under course content on Blackboard if anybody needs those remotely. Any questions about things before we get to it? Well, one thing we need to know about, and we're going to get the basics of graphing figured out, is something called an intercept. So how about we look at example 1 down here? Can you find the x-axis going across and the y-axis going up and down? Then you can see the line that's been graphed cutting across at an angle here. Remember that it doesn't really stop at the edge, it keeps going down and to the right forever, up and to the left forever. Anybody know what we mean by the intercepts of that line? There's an x-intercept, there's a y-intercept. There are points. Do you know what points they are? They're the points where the line intercepts, intersects, crosses. Yeah, the x and the y-axis. So if we check out our line here, find where it crosses the x-axis, that's going to be our x-intercept. So we're talking about a point or an ordered pair where the line crosses the axis. Looks like it crosses the x-axis at 3, so 3, 0. Like we saw the other day, we'll see those sometimes as ordered pairs and other times in the chart. A line can also cross the y-axis, so checking out the y-axis and where the line crosses it. What's the y-intercept for this one? 2. 2. So as an ordered pair, that would be 0, 2. Nice. Anything we can help out with there so far? Number 2 is real similar. See if you can find where that line crosses the x-axis and the y-axis. In other words, find the intercepts for number 2. Where does this one cross the x-axis? Looks like it's at 4. So 4, 0 would be the ordered pair. And what about the y-intercept this time? It would be at 0, -3. Nice. The axes were a little off center this time, weren't they? The x-axis was kind of high up there. Y-axis was just a little bit over to the side there. With what we've seen so far, could you finish off the definition up at the top? An x-intercept is a point where, what do you think? Something like point where the line does what?
Intersects the x-axis.
Sounds good. Where the line intersects the x-axis. You know, I've mentioned for our class we're really going to focus on lines, but any graph could have an x-intercept. So for us it's lines, but in general, any graph, if it crosses the x-axis, it has an x-intercept. It'd be nice if we could copy and paste that down here because there's only one letter different in the definition for y-intercept. Now we're talking about the point where the line or graph intersects the y-axis. So intersects, that's just another fancy word for crosses, where they come together, where they meet. See anything we can help out with so far? Well, at the bottom of that page, number 3 and 4, they are not lines, but they do still have intercepts. Take a second and see if you can find all the x-intercepts and all the y-intercepts for number 3 and number 4. If we were working on MATLAB, we would definitely want to put the comma and the parentheses. In other words, we want to write them as ordered pairs. And maybe sometimes there's more than one that you want to list. Looks like this parabola crosses the y-axis 2 places, doesn't it? Like positive and negative 3. So 3, 0 and negative 3, 0. Sound okay?
Yep.
And then the y-axis it crosses 1 time. Is that also a 3? Yeah. I hear a little bit on the microphone. Anybody trying to say anything?
No.
Oh, okay. How about with our circle over here? How many x-intercepts does it have? 2. Yep. And what about y-intercepts? 2. Yeah. If we're on homework and we're trying to list intercepts, it'll ask you to put a comma between them. So maybe that first ordered pair and then a comma and then the second ordered pair. Give you a second to see about filling in all 4 of those.
It would be 2, 0, and negative 2, 0.
That sounds great. And the y-intercepts are really similar, aren't they? Like 0, 2, and 0, negative 2. Nice. Anything we can help out with there so far? Let's peek at a homework question. Make sure we're ready for number 9 on the 3.3 practice. So here's another strange shape, not a line this time, but more of a V. It happens to be the graph of an absolute value. Notice they want us to identify the intercepts, type them as ordered pairs, use a comma to separate our answers. They're not separating the x and the y though, are they? We would just want to list all of them. So what some of them are for this graph? It looks like, make it a little bit bigger. Crosses the x-axis at -1 and 1. How about the y-axis? That one would be down at -2. Yeah, so we're just going to list them all at once with a commas in between them, like we have right there and right there. Remember, if you need a bigger picture, you can zoom in. You can make it a separate screen. Anything we can help out with there so far? All right. Well, check out all the intercepts we wrote down on the page here. Do you notice what they all have in common? 0. You got it. So what if we sort of separate the x and the y? Do you notice where the 0 is on all the x-intercepts? What's going on with those? For an x-intercept, the 0 is always The Y number, yeah. That'll help us out when we flip the page. Because we want to be able to find intercepts in other situations, like not just from the graph, but also from an equation. So noticing that all the x-intercepts we found have that 0 for the Y number. In other words, in the ordered pair, there's some x number first, and then there's always a 0 with it. That'll help us find x-intercepts using an equation. Like where it says example number 1 down there, what if we have the equation 4x plus 5y equals 20? If we're asked to find the intercepts, and we know the intercept always has a 0 in it, that's what we want to plug in to get started. So if I want to find the x-intercepts for this equation, I'm going to start by putting 0 in place of the y, like 4x plus 5 times 0 equals 20. And then I'll do all the simplifying and solving I need to figure out what x equals. So up in the box there it says to find x-intercepts, let y be 0 and solve for x. So we've put 0 in place of y, got a little simplifying to do. That's going to make a 0. And when I add 0 onto 4x, I still just get 4x. As you do several of these, you'll notice the 0 part really just disappears. So you might just jump right down to 4x equals 20. And then we'll solve. So it looks like x would equal 5. In other words, this line is going to cross the x-axis at 5. And then we want to do the same kind of thing to find the y-axis, the y-intercept. What we'll notice if we look back at our y-intercepts is the x is always 0. So we can fill in a few more blanks at the top. What all the y-intercepts have in common is that x always equals 0. So in the ordered pair, there's always a 0 and then a y number. So that'll help us find y-intercepts when we have an equation. Start by putting 0 in place of x, and then see what you get for y. Same idea as what we did here. We're just going to put 0 in the other spot. So that 0 part's really just going to get wiped out. We can do a little simplifying to show that if we like. Or if you want to just jump straight down to 5y equals 20. Looks like the y-intercept is at 4. So this same line is going to cross the y-axis at 4. With those two dots, we know where the line goes. We can connect the dots, make the line. That one's done. So the trick today to finding intercepts is starting with the zeros. You can see in our charts here, they were already filled in, but they won't always be. So eventually we'll need to remember for intercepts, start with 0. Find those 2 points, use them to draw the line. Anything we could help out with on that first one?
I have a question.
Sure.
So if we were to continue to find another number, you said we went with 1, would we place the 1 in either the x or the y?
Yeah, if you wanted to find another point, you could plug in anything you wanted. You sure could. Good question. Anything else so far? Let's use a homework question for our next example. So there where it says example number 2, let's try this one. X plus 2y equals -6. X plus 2y equals -6. So your turn to try it out with x plus 2y equals -6. You want to find the intercepts and then use those points to graph the equation. If you're not so sure where to start, remember we've got a little bit of a hint in our chart. Because we're looking for intercepts, we have to use zeros. Will somebody let me know what they got for the x-intercept when they're ready?
-6.
Oops, I put zeros everywhere. -6 sounds good. And how about the y-intercept? Will somebody know, or somebody let me know when they get there?
3.
I'm hearing a 3 and I'm hearing a -3. Could anybody help us break our tie there?
0, -3.
Another -3? Yep, but -6 divided by 2 looks like a -3. Anything we can help out with there? So we know this line is going to cross the x-axis over here at -6, and the y-axis down there at -3. We'll connect those dots to draw it in. You know, the other day we kept saying it doesn't matter which points you click as long as you get the right line. But today it does matter because they're asking us to use the intercepts to graph the equation. We really have to click those two or MATLAB won't count it right. Let's try clicking that answer in since that was a homework problem. So we're going to wake up the grid by clicking on it. Let MATLAB know we want to draw a line. Start at -6 on the x-axis. I'll click there. And then -3 on the y-axis. If I clicked some other point on that line, it would count it wrong. So make sure you're using the intercepts when it asks you to in this homework. You'll notice even when the line's done, oop, where'd it go? The dots are still there. Remember the other day the dots went away? But now because we're focusing on intercepts, they're still there. How about some of the questions for us so far on x and y intercepts? Both of the equations we looked at so far had the x and the y together on the left side. So those will all start to feel kind of the same after a while. Remember though, the x and the y aren't always together like that. Sometimes the y is by itself. So let's check out a few that start out y equals and see how that looks. Like y equals 3x minus 6. Still want to find the intercepts and use them to graph the line. We know for intercepts we've got to start with zeros. So let's plug 0 in place of the y, see what we get for x. And let's plug 0 in for x and see what we get for y. These two parts are going to feel kind of different because the x is not by itself, so we've got to do some solving to find the x answer. But the y is already isolated, so it's really just simplifying to find the y answer. Let's not think about solving for x up here. We're going to need to add that 6 to move it to the other side. And then to get the x all by itself, we'll divide both sides by 3. So the x-intercept is over at a positive 2. On the other hand, for the y-intercept, We just need to multiply and then subtract. So no solving to do, just some simplifying. That one turns out to be way down at -6. So we get a pretty steep line this time.
Okay, no question.
Sure, let's hear your question.
Okay, so, what I had did was I just went on and thought I was just dividing the 3x by -6, and I came out with -2. What did I do wrong? Do I need to go through and add the 6 to both sides before I?
Yeah, because we need the 6 to be on the other side of the equal sign
Oh, sweet, okay. I was
before we divide.
Okay.
That's right. Good question. How about some others so far? So let me give you a y equals 1 to try. Let's do y equals -2x plus 4. Your turn to try finding the intercepts and then using them to graph the equation. Would somebody let me know what they're getting for the x-intercept when they're ready?
2, 0.
2, 0? Sounds good. And what about the y-intercept? What are you guys getting there?
0, 4.
0, 4? Another pretty steep line. It's sort of flipped around the other direction though, isn't it? 2 for x, 4 for y, sounds great. How about some questions for us on that one so far? I want to look at one more that starts out with y equals, because there's something on homework that we need a little trick up our sleeves to get bigger. Let me bring it up and we'll try it for number 5. Let's see, I think it's, yeah, here we go. Where it says number 5, let's write down y equals -9x. Same instructions. We're trying to find the intercepts and use them to plot or graph the linear equation. So where it says number 5, we're going to try y equals -9x. Let me give you a minute to get started. It probably won't take long to see why I singled this one out. Anything kind of strange happening yet?
Yes.
Yeah? What is kind of strange about this one?
Okay, so are we gonna move the 9 or the x? We just need to go in.
We need to put 0 in for y and solve for x. And we also need to put 0 in for x and solve for y. That's going to be the easy one, isn't it? Let's just multiply those and get 0. How about to solve for x here? How would you get that x by itself? Divide both sides by -9. So x equals It's a little strange because everything turns out to be 0. In other words, this line crosses at the origin. So the x and the y intercepts are the same point. There's not two separate intercepts, it's all one point. That's going to be a little bit of a problem when it comes to drawing a line because we don't know which way to angle it. All we know so far is it goes through the origin. Any thoughts how we can figure out which direction it goes from the origin? Here's a little something that might help out right here. Since the intercepts are only giving us one point, how can we find another point that the line goes through?
And
Plug in some other number, maybe a 1. See what you get when you plug that in. Like if it's y equals negative 9x. Remember the other day we said you could plug in any number you wanted and then see what you get to find what ordered pair would be on the line. Looks like this line also goes through the ordered pair 1, negative 9, so way down here. So that's the trick. When you don't have enough points from the intercepts, you could plug in any other number to get that second point. Remember on homework MATLAB, you got to click 2 points to anchor that line. So if you don't have enough, just plug in some other number. So I want my line this time to go through the origin. I'll click there for sure. And then whatever other point you found, like 1, negative 9 was mine, helps you know which direction, which angle the line takes. So that's a homework question that'll allow us to click any other point because there weren't enough intercepts. If there were 2 intercepts, we would have had to use those 2. But there wasn't, so we have to do some other point. When we flip the page, we're going to look at something a little bit different. Any questions about intercepts before we see what's next? All right. Let's see. Here we go. So it says we're going to look at some special lines. In particular, a horizontal and vertical. Can you tell which one is horizontal, number 1 or number 2? Number 1, yep. Anybody have a way to remember which one is which?
thinking of horizon, I think that equals something.
Yeah,
Sunset.
I've heard that before. That's a good one. Because this line looks kind of like the horizon, we can remember that's the horizontal. And remember that line, even though it looks like it stops, it actually keeps going to the left forever and to the right forever. Let's investigate it a little bit. Could you tell me some points that line goes through to help fill in the chart here? What are some of the points on the line? Maybe something like
2 and -2.
2 and -2. Good one. That would be this point here. We could use a few more. What other points does that line go through?
6, negative 2.
6, -2. Nice.
Negative 3, negative 2.
-3, -2. Good one. Are you starting to notice what all of the points on this line have in common?
Mm-hmm. The Y.
The y. Every single one of them has a y of -2. Turns out x could be anything. Here's the positive x's, here's the 0, here's the negatives. The y is always -2. That's what makes it flat, right? Because no matter what x is, we're always going to go down 2 spaces. So the rule for this one, y is -2. That would help us write an equation. What would the equation be if the rule is y is -2? instead of y is, when we translate it, what would that look like?
Equal.
Equals, yeah, y equals -2. There's no x in the equation because x doesn't matter. X could be anything. All we have to be sure of is that y is -2. That's what all these points have in common. So let's see down below where there's some blanks, the ones that talk about the horizontal line. What we're seeing here is the equation is going to start out with y equals. So the graph of y equal any number is going to be a horizontal line. Which axis did it cross? Does it have an x-intercept or a y-intercept? Y, yeah, it crosses the y-axis. And where it crosses is at that very number. So the equation kind of tells us everything we need to know. This line is going to cross the y-axis at -2. We'll find that the vertical line works really similarly. We'll check that out in a sec. If there's anything you want to back up and ask about what we've seen so far, just let me know. So vertical, that's when the line goes straight up and down instead of straight across. Kind of like we see over here. Keeps on going up forever and down forever. How about some points on that line? Could you give me some ordered pairs for this vertical line? Like where's the intercept? The ordered pair? 3, 0. And maybe we could identify something up here in the first quadrant. What would one of these points be?
3, 2.
3, 2, yep. And then there are also points in the fourth quadrant. What would one of those be? Maybe 3, -3. So what are you noticing about the points on this line? What do they all have in common? That x is always 3. X is 3. That would help us write an equation. X is always 3. That would be x equals 3. So anytime we see x equals, we know it's going to be straight up and down. It's going to cross the x-axis at the number that we see. That'll help us fill in a few more blanks. The graph of x equals any number. It's going to be a vertical line. It's going to cross the x-axis at that number. So we'd like to be able to recognize the equations for these special lines, like the x equals or the y equals. And one way to spot them is they'll never have an x and a y. They just have one or the other. So if you're missing an x or a y, it's going to be either horizontal or vertical. They're pretty easy to graph once you get the hang of it. Like number 1 down here at the bottom. It's asking us to graph y equals 3. So we know this one's going to cross the y-axis at 3. If that's the only intercept, would it have to be horizontal or would it have to be vertical? Horizontal. So if we notice which letter we have, that'll tell us what axis to cross. And then the number tells us where to cross it. That would definitely be horizontal. Some students in the past have said, if you make an upside down y, let me make a y and flip it upside down, it looks kind of like an H. So an upside down y looks kind of like an H. That helps us know that one's horizontal. Maybe you've got your own way to keep it straight, but that's really the tricky part in the end, remembering which one is which. On the other hand, when it starts out with X, do you notice that the top half of an X looks like a V for a vertical? So number 2 there is going to cross the X-axis at 1. That makes it a vertical line. On the next page, we're going to practice graphing some more of these special lines, and then we're also going to practice going the other direction. Like if you have the graph, trying to come up with the equation. So if things are seeming okay, you might flip on over, try that 3 through 10. If you need to back up, asking questions. Nope, I see that the screen froze on some of you. I'll leave this up for a minute so you can catch up, and then we'll see if we're all getting the same answers on that next page. If anybody's needing a little help right now, just let me know. Anybody need a little help getting started or catching up with us there? Could I use a lot of help on this next page? Would you let me know about number 3? Did you go with horizontal or vertical? Horizontal. So straight across, gonna hit the y-axis at -2. Sounds good. What are you guys thinking for number 4 then? Horizontal or vertical?
Vertical.
Vertical, all right. So this time the x-axis at -3. Great. Anybody need a little help there so far? Is 5 going to be horizontal or vertical?
Vertical.
Vertical. The thing that makes 5 a little tricky is that 5 halves, isn't it? If you're not real sure where to put it, you might divide 5 by 2. Looking at it as a decimal or a mixed number makes it a little easier to know where 5 halves is going to go on the number line. So we want to cross the x-axis at 2.5. In other words, halfway between the 2 and the 3. And like I said, vertical line from there. So not on the grid exactly, but halfway between the 2 and the 3. On number 6, can you tell me which axis that line crosses? X or Y?
That's just the Y.
Y, all right, so it's going to start out Y equals. Y, yep, sounds good. And then number, it crosses at 2, so it's going to be Y equals 2. If anybody needs a little help with that one, let me know. Otherwise, see if you can go ahead and finish off 7 through 10. should be?
X equals 1.
Maybe a -1? That's
Yeah.
over on the left side? Yeah, nice. Nice. Now, Andre or Olivia, what are you getting for number 8?
-4. Y equals -4.
Y equals -4? Nice. Jeremy or Maya, could you help us out with number 9?
Yes.
I'm seeing an X equals 4 on the chat. Nice. Crosses the X-axis at 4. Great. And what about this last one? Should we start with an X or a Y? Y. And it looks like it crosses at 3. Y equals 3. Our youngest classmate's not happy with that one. Any other thing we can help out with there so far? So let's check out a couple of those on MATLAB, because things sometimes look a little different when they start going straight across or straight up and down. Number 4 here is asking us to graph x equals -8. We can tell it's a little different, one of these special lines, because there's an x but not a y. So what do you know? That one should cross the x-axis at -8. So let's definitely click a point there. But then where else do you think we should click? Yeah, remember we want this to be vertical, so I could go straight up and click any of these points, or straight down and click any of those points. Anything that makes that straight up and down vertical line that we want. So the axis is a good place to start, and then anything straight up or down from there help you make that vertical line. Sound okay for starters? Then there's one other one to peek at, because it looks a little bit different at first. This one says y minus 4 equals 0. What's kind of different about that versus the other horizontal and vertical lines we've seen so far? It's arranged a little bit differently, isn't it? On all of ours, the y was by itself. So what would it take to get that y by itself? Wouldn't you need to let's solve for y. Well, let's write it down. It says y minus 4 equals 0. How would we get that y by itself? So it would be y equals something.
Add the 4.
Add the 4. Nice. So move the 4 to the other side, get the y all by itself, and then it looks like we're used to. So y minus 4 equals 0 is the same as y equals 4. So should I go to 4 on the x or the y-axis? Y-axis. Let's click there, and then where else should I click? Anywhere. So either straight over to the right or straight over to the left. That'll do it. If it looks a little funny, just get the y by itself like we're used to, and then it'll work just like all the others. Anything you want to ask about the special lines, vertical or horizontal on MATLAB? All right. So flip in the page again. We've got this crazy looking grid with 10 different lines graphed on it. Let's see if we can figure it out. We've got the x-axis going through the middle here. And the y-axis also up and down through the middle. what we're wanting to do is match each of the equations at the bottom with one of the lines on the grid. That means the lines need some labels or something. So I'm going to start by calling this line A right here. And then I'm going to keep going up. That's going to be B, C, D, and so forth. As we make our way across the top, we've got F, G, H. And we've already called that one A. There's a few more over here that don't have a name yet. Let's call that I. Let's call that J. I think that's all of them. And then let's check out the equations down here. If I could find the intercepts for this equation, I could look up on the graph and see what line crosses at those intercepts, and I know which line to match it with. So maybe we'd start by plugging in some zeros, like 4x minus 5 times 0 equals 20. We'll see what we get. 4 times 0 minus 5y equals 20. See what we get. Looks like the x-intercept for that first line is at 5. So I'm going to look for my x-axis here at 5. There's quite a few lines going through that point, so we've narrowed it down a little bit, but not all the way yet, have we? Better figure the y-intercept. 0, y. Looks like it's at -4. So we want to know which line goes through the x-axis at 5 and the y-axis at -4.
J.
J. Good deal. That's the only one that crosses here and here. So we've got a lot of intercepts to find. Lots of zeros to plug in. Let me leave you to it. If I need a little help getting started, let me know. Looks like number 2 also has an x-intercept of 5. So another one of the mini lines going through that point. For the y-intercept, I got 3. So up here, we want to know which one goes through there and there. What should we match number 2 with?
C.
Is that one going this way?
C.
It looks like F. See what you think? C's over here.
Yeah.
Let me know when you get something matched up and we'll add it to the page here. Like maybe number 3. Let me know when you're ready for number 3.
G.
G. Sounding good. Number 3 had an x-intercept of 5 and a y-intercept of 4. G looks like a perfect match for that one. When somebody's ready to help us out with number 4, let me know.
Which number?
We're ready for number 4,
I got E.
E. That was good. That's an x-intercept of 5 and a y-intercept of 2. Andre, could you help us out with one?
For 5, I got D.
D.
Yeah.
So D has a -4 for x and a -5 for y. I had those flipped around. I had -5 for x and -4 for y. What about other folks? Are you getting?
I think it's B.
So that would have been a B, you say? Okay. Oh, now we got an A. Getting lots of choices.
I got B.
Another B, okay.
You got any?
I got E.
Yes, I mean. Oh, because it is -4. Let me look at 4.
Let's see, so x would equal -20. That means x is -5, so we want this point here. And 5y equals -20, so y equals -4. Oh, sorry, I went the wrong way on the x, didn't I? Scratch that. -5 on the x-axis, that's this one.
Too many lines.
-4 on the y-axis, this one.
Yeah.
So we want
B.
B. Yep. Anybody have an answer for 6 to share with us?
I got I.
I.
Ooh, the paper.
Sounding good. Do we know what to match with 7 yet?
I got D.
D. What about for 8? Do we know?
A.
A. And look how different 9 and 10 look. They don't have an X and a Y. They only have one or the other. So that's our special lines. When you see just an X and not a Y, that's the vertical one.
H.
When we see just a Y, not an X, that's the horizontal one. So H, that sounds good. And what does that leave us with for 10?
C.
See? Nice.